Okay, good day, guys. Welcome to IC Education, the only education that matters. Today, we are doing Centroid. Okay, I was explaining, Andile, when we have, let's say, a square, and we have another square inside. The one inside will be minus, basically, because we are removing. It's like a halo, it's like a wall. That's why it is always minus. So the first step of solving this problem is to set the reference, and we both agree that we're gonna keep it standard to always take our top as reference. So first thing we can take for shape 1, what we do is we know that our y total, y bar, is equal to what? To a1 y1, right?
Okay.
Plus a2 y2 plus a3 y3, everything divided by a1 plus a2 plus a3. Now, how do we do this, Angela? Now, first of all, we can deal with shape by shape. Some people draw a table, but I just find it long. The way we do it is, we know that this is a rectangular, right? For shape 1. We can start by finding a1 and y1.
Yeah.
So what is the area of the rectangular? It is base times height. So it is 160. Please take your calculator so that we can be fast. Times 40.
Okay.
Now, how do we find the y? Y is the distance from the reference plane to the center of gravity of this shape here. The center of gravity of this shape is found in the middle, at the midpoint. So what is that distance? You first have, remember what is the distance? This is 80. You first have 80, then plus 20. Do you see it, Angela?
Yeah.
So definitely this is our this is our a1 y1. So what is the answer on this one?
$100.
Oh, it is 100, this one, eh? It is 80 plus 20, sorry. Now, I mean, what is the total answer for?
Okay. It's 640 times 10 to the power 3.
It is 640. Like this.
Yeah. Times 10 to the power 3.
Okay, we'll see the unit after. We'll see it when we combine everything. Now, can we do a2 and a2 and y2? Can we do that? Remember, a2 is this rectangular here, right? Hello, Andile, are you with me? Let me check.
Yeah.
Okay, thank you. What is a2? A2 will be 80 times 80. Right? Now, what is the centroid? Because the centroid is found at the center of this rectangular, which is what? 40. If 80 is the full length, it is 40. But remember, we are reading from top. So it's going to be from top until that 40. So it is 80 times 80 multiplied by 40. So what is the unit here?
It's 256.
256. Yes.
Times 10 to the power 3. Times 10 to the power 3.
Okay, Danko. Can we do a3 y3? What is a3 y3? It is rectangular inside, right?
Yeah.
And I just said a statement where before we started. I said when we have something inside, what do? We subtract, right? Yeah, so for this one, we're going to have negative. What is the area?
area, it's 40 multiplied by 40.
Thank you. 40 multiplied by 40. Now, what is the y? Remember, y it has the center here. So, center of this small rectangular, which is 20. But since we are taking reference from top, so we have to read from top until where the middle is, which is basically 40 as well.
40. Yes.
Yes, let's do it quick. What's the answer?
Negative 64 times 10 to the power 3.
Okay, thank you. Negative 64 times 10 to the power 3. Can we do this calculation? This unit here in millimeter. Okay, can we solve for y bar straight? We can.
Okay.
Yeah, it's going to be 640 times 10 to the 3 plus 250, 6 times 10 to the 3 minus, this one was 640 or 64?
64. Let me see. Yeah, 64.
Okay, no problem. Now, what do we do with areas here? What is area 1? Area 1 is 160 times 40. Do you see it?
Yeah.
Plus, what is area 2?
It's 80 times 8.
80 times 80. What is area 3? Area 3 should be minus as well because it is the area that is being removed. Do you see it?
Yeah.
Yeah. What is 40 times 40? So what do we get as y bar? This is just the general formula, but as you look at the sign of what is being removed, you include it as well. What do we get?
We get 74.
Okay, you get 74,
comma 286.
74,286. Okay.
Yeah.
Let me write it down. Okay. Millimeter. Now, what do we do now? What we do is we come to our original drawing here. We represent where is 74. Remember, when you solve a problem like this, you should always say what is your reference. If you get it from top, you should come and write from top. Right?
Okay.
Yeah.
Okay.
The person that is marking should know where are you getting this, because the solution might change depending on who is taking his reference.
Okay.
Now, how do we represent 74? Do you agree that if from here to here is 80, so 74 has to be somewhere here? Let me use my ruler. It is nicer with the ruler. Technology. Do you see my technology?
Yeah, I can see.
Okay, do you see the axis that I drew here?
Yeah.
This distance here, from this axis to there, this is the y bar that we find.
Okay.
Yeah, that's how we do it. Now, what do we do? We can now start by solving for what? For... So now, can we start by solving for Ix? Ix will be referring to this. How many shapes do we have? 3, right?
Yeah.
Let's start with what we call shape 1, which is the big rectangular here. Let's call it Ix1. What is the formula? It is b times h cube by what? 12. This is the formula of a rectangular. Now now if we have parallel axis, what do we say? We said plus a multiplied by what?
H
square. Okay, now in our shape 1, it is this rectangular here, right?
Yeah.
So first of all, we have to see where is the y bar. This is the y bar axis. Do you see it?
Yes.
Where is the axis of this shape? At the center is this one.
Yes.
If these two lines are parallel, therefore we have parallel theorem. So basically what we'll be having, what is b? B is 160 times 40 cube divided by what?
12.
By 12 plus what is the area? 160 by 40. Yes, let's do it quick. Multiply by what?
40 squared.
Multiply by now we have to find out what is the distance from this center of gravity to this one square. How do we find it? That's how we do it. If this is y bar, what calculation can we do to get this remaining? Let's think together.
I think it's gonna be 80.
Okay.
Minus.
We have
minus
80
minus 60 plus 20.
Okay, yeah. So basically it is 80 minus 60, which gives this remaining here, and then we add 20. Yeah, that's it. So what is that value?
I think 40.
It is 40, no? Because 80 minus 60 is 20. Yeah, plus 20. This one gonna give what? 40 square. Yeah, let's do it fast since we understand what's happening. What is Ix here?
Still calculating. It's 1.10. 1.10.
It's 1.10.
It's 1.109.
1.109, like this.
Yes.
There's no time 10 to the something, just like this.
Times 10 to the power 6.
Okay. Millimeter 4. Can we do for this one, this other shape here? Can we do for the second rectangular here?
Okay.
Let's call it Ix2. Okay, do we see a parallel line here? If this is where it is catching, where is the center of gravity of this guy? It is here at 40, right?
Yes.
Because these two lines are parallel, we have the parallel axis. So first of all, what is the base and what is the height? This thing is 80, right?
Yeah.
So it is 80 times 80 to the 3 divided by what?
12.
Plus, what is the area? 80 times 80, right?
Yes.
Times, what do we have now?
H. We are looking for H.
H is the distance from this one, the center of gravity, to this square. Now let's do our math. How can we get this? I think if we take y bar minus 40, can it give that?
Y bar minus 40. Oh, okay. And then we'll remain with 20.
We'll remain with this one here.
Yeah. Okay.
Is it-
Okay.
do you see it now?
That's yeah. I see.
So which is what are we getting here? It is y bar is what?
74.
Comma 286 minus what?
40
Everything what? Square.
squared.
What's the answer?
It's 10,
It's 10
comma 937.
times 10 to the 6.
Yes.
I wanted to ask again, how did we find the distance of the first rectangular again? The h.
We said 80,
Hmm.
and then we said minus 80 minus 60 plus 20.
Now I'm just worried because we did not include y bar in this expression. But let's see. We
Oh,
said, well, no, it's fine. It's fine. If it makes sense, it makes sense. h is here, right?
yes.
Because the distance was here to y bar. h minus what?
Minus 60.
Where was the 60 coming from?
40 plus 20.
Oh, no. That's the mistake that we made there.
Okay.
Do you see why? we are
What?
we are not really sure where this axis is passing. We don't know if it is passing here to say it's 60.
Okay.
Yeah,
So we have to use the
yeah,
the y bar.
you have to use the y bar.
Okay.
So basically
Okay.
it's going to be h minus y
Y
bar,
bar
which is gonna
plus
be
20.
plus 20. Yes.
Okay.
Do you see it now?
Yeah.
I was just worried for all the distance the y bar should be included. So
Okay.
so we have h minus 74 comma 286 plus what? 20, right?
Yeah.
Square. What's the answer now?
It's 5.
The answer is 5.
5.09
5
times 10 to the power
okay.
09 times 10 to the power 6.
Okay, no problem. Can we go to ix3?
Okay.
What do we have? Remember, ix3, the distance will also gonna be from the center here to here. That distance would be the same as the one of ix2. I don't know if you see it. Because the center of gravity of the small is the same as the big one here.
Oh.
You see the distance.
Okay.
What will change is simply the area and whatever there. What is the base? The base is 40, the height is 40. Right?
Yes.
40 times 40 cube divided by what? 12
12.
times 40 times what? Times 40 multiplied by that distance should be the same. 74,286 minus 40 square. What do we get as answer?
So it's gonna be 74,286 minus 40 ohm.
Yes, just the same as this one. Remember, we still want this distance here, which is the same also for the small one, which is
Mm,
y bar minus minus 40. It's gonna give us the remaining, which is the same also for the big one.
oh, the problem on the first one, we
We
okay,
subtracted.
okay.
Okay, no. I see what you are saying. The answer like
Mm,
this.
okay.
Hmm. Do you see it now?
Yeah.
Yeah, it has to be minus because that thing is subtracted. Thank you for reminding me.
It's negative 3.
Hmm.
0.975 times 10 to the power 6.
Okay, now we know that how do we get ix? Ix is the sum of ix1. Can you type in the calculator? Ix2
Okay.
and ix3. What is the answer?
It's 12.052.
Getting 12.052. Final answer.
Yes.
Times 10 to the 6. Nah, that is not what they are getting. So something is off here. They are getting 13,928.
Hmm. Okay, let me try to verify my calculations.
This one is right. We need to get this answer. What when you check, what do you have?
Um,
I don't know what went wrong, but let's check it together. Let's start by this moment of inertia, the first one. 160 by 40 divided by 12. 160 by 40. Now we want the distance from here to here. We know it is h minus y bar. H minus y bar plus 20. That is making sense, no?
yes.
H minus y bar, it gives the remaining now, plus 20 square. So basically what we have, it is 100 minus y bar. So when you put in your calculator, what do you get? 5,09 times 10 to the 6.
Yes.
Okay, let's double check for ix2. ix2, it is he times he divided by 12. This is cube, ne?
Yes.
he times he multiply. How do we get the distance from ix2? ix2 to center of gravity of this to ix2. I mean to this center here, this h here. We said it is what did we say again? We say it is y bar minus 40, y40, y bar minus 40, which at the center here, 20 plus 20 at the center here. It gives us the remaining everything square. Can you double check the calculator? How much is this one?
Has still 10.937.
10.937. Okay, let's look at this one. 40 times 40 times this. Now we have this one as well. On this one,
40 times 40 cubed. Oh, that's half. That's 40.
what do you get?
2.
Yeah,
Point.
yeah. If it's 2, this should be, it is
0.094.
So the answer here is 2.094.
Yeah, negative.
2.094. Can you now do this calculation and see what we get as answer? This should give 13.
Okay. Yeah, 13.933.
Okay, that's the answer. So what does it mean? It means we have to double check our calculator.
Yes.
This is what they got. Okay. Are we on the same page? But now, can we solve for EY? Right?
Yeah.
EY will be EY1, EY2, but remember, we do not have any X bar here, so the assumption that we are making here is that this Y-axis here is passing through the center of gravity of this guy here. Let me use my technology. Yeah. Hey, it moved. What's going on? This thing is moving. Anyway. Anyway, this is the axis y. Now, because this thing here is passing where the center of gravity of this shape is at the center here, we do not have what? Parallel theorem, right?
Yes.
So because of that, our IY is simply gonna be this part here, this part here, and this part here. Can you do this calculation, please? Adding only this part, this one, and this one.
Okay.
Let's see.
It's 4,053.
The total IY.
Yes.
Okay.
Do you
Why?
also minus or we add
No,
on it?
you subtract the.
You subtract, yeah, it's 4,053.
No. Something is off because they are getting 16. Do you see it? So on this, I think I think the assumption should be a problem. Let's do this. Let's try something. Can we try to solve for x bar?
Okay.
Now we are taking reference from left to right.
Yes.
Right? Now what is happening if we take the first shape? So we're just gonna do it quick to see what if we have to solve for x bar for us to get that other thing there. Now, do you agree this is shape 1? So x bar will be at the center here, right?
Yes.
So in this case, we'll talk about a1 x1. Do you see it?
Yes.
What is a1? 160 times 40, right?
Yes.
What do you think? Should we type it straight on the calculation
Yeah, it's
to
fine.
save time here? Oh, what is this ruler coming now? Okay, what do we have? We have x bar. What is x bar? A1 x bar, which is 160 times 40, right?
Yes.
Now, what is that distance? The distance is from here to the middle here. What is 160 divided by 2? It's 18, eh?
It's 8.
We go plus. What is the other guy? Remember, the reference is still from here to here. Do you agree that all these references will be 80, 80?
Yes.
Do you agree, right? Can we take the second area? It is 80 times 80 times 80, right?
Yes.
Now, can we check the last one? The one inside that we'll be removing. We know it's going to be minus. Minus what? 40 times 40 times 80. Do you understand why is it times 80? Because we are still writing from our reference point to the middle, which is still 80. Now, what is our total area?
It's 896
800
times 10
times 10 to the power
3.
Okay, it's the same one as the first one, right?
Yes.
What is the answer of x bar?
It's 62.
It's 62.
0.22.
$62.22, right?
Yes.
Okay, I believe that everything is right here. Okay, where is 62.22 if we have to represent here? If this is 160, 62 I think should be somewhere here. because HE is in the middle. Do you see it?
Yeah.
So this is our, let's call it, oh, let me use the ruler so that it can be cleaner. Do you see this axis? We can call it YY, right? Where we will be reading. Now, can we solve for? Let's start by this moment of inertia. Can we solve for IY1, right? What is IY1? It's going to be all these things that we see here. Do you agree first we have parallel axis? Center of gravity of this shape is in the middle, right? These two lines are parallel, so there's parallel axis here. So we need to find this distance. Before that, we can use everything that we know. This formula and then this area. What will change is the distance.
Mm-hmm.
It is 160 times 40. Is it cube?
Yes, cube.
Yeah. 12 plus 160 times 40 multiply by what? What do we have now? Now let's look at our distance from there to the center of gravity. Remember, now we are reading now from left to left, from left to right. How do we get this distance? If from here to here is our x bar, do you see it?
Yes.
Now how do we get this distance here? So x bar is going to be HE. Do you see it? Because at the middle here it's HE.
Yes.
It's going to be HE minus x bar. Do you see it?
Yeah.
What is that distance here?
62.22.
It is 62.2. Oh, no, it is first HE minus 62.22. What is the answer?
2.876.
It is 2.8
Yeah. 77.
times 10 to the 6. Okay, can we find IY2? Now you can take it. You can take it.
That's fine. I can continue.
Okay, what is IY2? It is HE times HE cubed divided by 12. What is the area? The area is HE times HE. Now, what is the distance of x bar? Now we have to look. I think they will all be the same, eh?
Yeah.
It's going to be HE again minus this because the reference is this one. We have HE minus, so we know we're gonna keep this distance here. What is the answer?
It's 3.35. 3.5. 7.
Times 10 to the 6.
Yeah.
Nah, I don't think we're going to get that answer. Why do you think I'm saying that?
Because
the last one will subtract, and this 2 is already 5. Anyway, let's go. What is IY3? IY3 is 40 times 40 cube divided by 12 plus 40 times 40 times the distance 80 minus 62,22 square. What's the answer?
It's negative.
Negative?
I deleted it by mistake. Yeah, negative 719.
Negative 7 1.
9.
Negative 7,1 or 7 1?
719, comma 138.
Negative 719, comma. Oh, are you sure this is right?
Yeah.
Like this. So
Yeah.
7 1, comma.
Comma 139
Times.
10 to the power 3.
Okay, this is 3, yeah. Okay. Then that should give us the correct y bar. Why is it wrong? Are we good here on this x bar here? And this times 80. The middle, this time 80. Minus this time 80. Are you sure about this area?
Which area?
The total area.
Yeah.
When you did this, you subtracted 40 minus 40.
Yeah. I think so.
Can you
Let me double check.
Yeah, please, let's double check, please.
Oh, the answer is 8.
Why is 8? Which one is 8?
The x bar.
The x bar here is 8.
80.
Oh, you see.
So
It's 80
80.
on the dot 80.
Uh,
So this area is fine, right?
which one?
This area here, total area.
Yeah.
Okay, if it is 80, so it means where there is 60 here, we replace by 80. What are the new answers?
Okay.
Oh, you see what I was saying? If it is 80, that's why I was saying there's no need of y bar. Do you see it?
Yeah.
Because if there's 80, all this gives 0. Only this part exists. That's why I was saying that for y bar, we don't need to. This is actually a good example of proving it. We don't need to solve for x bar actually. Do you agree that if this is 0, this is 0, this is 0, then this is 0, right?
Yeah.
The only thing remaining is this one. Can you please double check please this calculation? What is I total? It has to give us this 16,85. Please check it again, please, and then we can move to 9.2, please.
It's still 4.
It's still 4.
4,48.
Something is off. Let me take my calculator as well and try.
Okay.
Yes. Hello, can you hear me now? Okay, I don't have a calculator. I do not know the reason why we're getting 4, but we suppose. Okay, on its own, how much is this one? 120
Okay.
times 40 cube.
It's 853.33 times 10 to the power 3.
Hmm? It is 160
Times 40 cubed
times
divided by
40
12.
times 40. It is 8 comma.
It's 853.
The answer is 8853.
853, comma 33 times 10 to the power 3.
Okay. Yeah, what is the next one?
Okay.
80 times 80, so 84 times.
It's 18 multiplied by 80 cubed divided by 12. It's 3.413.
3 point or 341?
3.41
Mm-hmm.
times 10 to the power 6.
Okay. What is the last one?
It's 213,
213
comma 33
negative 213
yeah,
comma 33.
times 10 to the power 3.
Okay, can you add this like this, separately like this? 10 to the 3 plus 346 10 to the 6 minus 2133 10 to the 3. Please,
Okay.
we need to get that answer. This is actually a clear example of showing that.
4 still.
Yeah?
4.
Then something is off. I don't believe it's us. Anyway, can we check this guy here, the second one, and then we can, if we can finish this, we can check that other chapter quickly. Okay, let's do this quick because I do believe that we are on the same page. Yeah. Are you watching the okay, no. Skyward. Okay. First of all, we have to identify what?
Center. The reference.
Reference plane. We agree, you and I, we're gonna use what? Top, right?
Yeah.
Yeah. Oh, this ruler makes it nice. It makes my work nice. So what do we do? Remember, this is an allo. An allo is simply a combination. I'm wondering if this thing does not have shapes like circle or what. Let me just check. They have image. They have templates. Oh yeah. Technology. I know. I will learn this technology after. Anyway, we don't have time to be learning this. If you have a circle inside a circle, we call it an allo, right? An allo shaft. Do you know what's an allo now?
Yeah.
Yeah, for this it means you have two diameter. You have the outside diameter, which we call big G, and we have the small diameter. Okay, this is the small diameter, this is the outside diameter. It's not looking nice like that. But no, okay, why am I wasting my time there? Do you see this thing here, like this one?
Yeah.
You see a bigger diameter, which is for the circle outside. Do you see it?
Yes.
You see a smaller diameter, which is for the circle inside. This type of shape is called allo. We usually see it in shafts. If you draw a shaft in 3D, an allo shaft, I think we've seen something like this in steel strength. If I put a wall here, do you see this wall?
Yeah.
This create an allo. Now, for a allo of the circle, what you need to do, moment of inertia passing through its center of gravity, I, either Ix or Iy. When it passes through its center of gravity, it is pi over 6,4. Do you see it? Diameter,
Yeah.
big diameter 4 minus small diameter 4. Now, what is the area for an allo? Remember, the area is simply the area of a circle. Because it is two circles, it is basically pi over 4. Do you see it? Big D square minus small d square. That's how it is done. Now, what do we do? How many allos do you see in this problem?
2.
Okay. In another word, basically, if I can show you how it is, how do we get to this to make it actually clear? If you have the circle on its own, do you see it? This circle outside, moment of inertia is what? It's simply pi over 64 what? d4, right?
Yeah.
Do you see the circle inside? What does it mean? It means
Minus.
we are removing. Minus what? Pi over 64 what? Small d4. So basically what they do, they simply take as common factor pi over 64, which gives you this.
Okay.
Same is applied with the area. To avoid that you should repeat yourself, you can just consider them as one and apply the formula. That's basically where it comes from. Okay, since we have how can I say it, we have set our reference plane. I think we can start solving the problem, right?
Yeah.
Okay, here we go. Let's go fast. This one is the center of gravity of a circle is at at its center. I don't know if my English is making sense. The center, or not the center, the centroid of the circle is found at the center of the circle. What is that English? My English is, do you understand what I mean? Eh?
Yeah, I understand.
So now let's start with what we know. Let's go with what? A1 Y1, right? Okay, A1 here, we just consider the allo, everything, which is what? Pi over 64. Do you see it? What is big diameter? There, it is 80. Square. No, I'm making a mistake. It is not pi over 64. It is pi over 4. Pi over 64 is the moment of inertia.
Okay.
Minus 50 square. Now, what is y? Y is the distance from the reference plane to the center. What is that distance?
Is that from which diameter?
No, it starts from the top to the center.
Oh, so it's 40.
It is 40. Kibukai answer. Answer Kibukai.
It's 1 to 2.
1,22 or 122?
122, 522 times 10 to the power 3.
Okay, it's fine. It's fine. Can we go A2Y3? A2Y2. What is A2? It's the rectangular. Do you see it, right?
Yeah.
So it's 15 times what? 200, right?
Yeah.
Now, times what? What is the y? Y is the distance from top. What is the center of gravity of the rectangular? It is at its center, right? Which is what in this case? It is 100.
100.
But remember, because we are taking reference from top, what would be the distance then?
It's 108.
It's gonna be
108.
808 here. The diameter of that guy plus 100. What is the answer?
It's 540 times 10 to the power 3.
It is
540 times 10 to the power 3.
okay. Can we check the third one? A3Y3.
Okay.
Do you agree this is an allo, right?
Yeah.
So it's pi over 4. What is the big diameter? 120 square minus 90 square. Multiply. What is the distance from reference point to this center?
80 plus
200 plus 60.
6.
What is the answer? Oh, plus 60. What is the answer?
It's 1,682.
682.
Yeah, 1 comma
682
times 10 to the power 6.
Okay, let's just make sure that everything is correct before we put on. Okay, let's just calculate and see what's the answer. Let's go to y bar. What will be y bar? We add all this one by the area. But remember, because the subtraction is being done in the allo formula, you don't need to put the minus again. I don't know if I'm making sense.
Yeah. That makes sense.
Now, in terms of area here, what do we have here? We have pi over 4. It is very, very important to remember that. Tomorrow's class will be long, eh? You have to be prepared.
Okay.
Yeah, I know that I didn't really show up last week, but I don't want to lose you one day. You already had the back thought, this guy. So I have to make it up to you. 122, 52. 10 to 3 plus 5 4 0 10 to 3 plus 1 6 8 2 10 to 6. What is the answer of y bar? I think we need to get what is the answer of y bar?
Just
It does.
give me.
Check it. Yes, what do you get?
2 minutes.
No, take your 2 minutes. Take even 3.
Okay.
What do we get?
59.
We cannot get 59 because on the book here they are getting 2 1 12.
2 and 12.
No, and we are taking the reference from top, so we need to get the same thing. If we don't get it, something is wrong. Pi over 4 he square minus 50 square multiplied by 40. Can we double check that one? What is the answer there?
Double check which one?
The first a1 times y1.
Oh. Yeah. Oh, times 4. It's 1 to 2.
It's 1 to 2 to steal.
Yeah.
Okay, can you double check please? A2 and y2.
It's 5 40.
And the last one is 1 6.
Oh.
Yeah, what?
It's 60. It's 296.
This answer here is 296.
Yeah.
Yeah, that's why we have to be careful with the calculator. 296,
881.
296, 881.
Okay, not ice
Yes?
on A3Y3. Why did you say times 60?
What is it supposed to be? No, it's 60 plus this plus this plus that. Nah? It is it is 80 plus 200 times 60, which is what? Yeah, that's where the mistake is. Sorry, my brain have been thinking from the morning until now. It's been working over time. Now, 80 plus 200 plus 60, what's the answer?
It's 59.
It's 49.
59.
No, it's not 59. I'm saying the distance here. What is that distance? 80 plus
Oh,
plus 200 is 280. Plus 60, it has to be 340, ne?
yeah, 340. I was calculating the
Oh,
whole
the whole thing, what? How much did you get?
59.772
59.772 times 10 to what?
to the power 6.
Okay, this can give the answer. Let's check. This can give it. So please follow what I'm doing. At this stage, it's easy for me to make a mistake. I haven't tested yet.
Ice.
Yes, what do you get?
Uh,
Tell me it's 212.95.
no. I was double checking something here.
Yes.
On A3Y3, the first answer was correct.
Huh?
Yeah, 1,682
Even
was
when
the
you do
correct.
340 is correct, it's still correct.
Yeah.
Now I'm losing it. Now my brain, what's happening there? Okay, we need to find. Okay, no, we need to get this answer. We have to get it. Let's try again. No. What's the problem, Andile? We are getting this one. Otherwise, we don't sleep. Now, pi over 4, 80 minus 50 square times 40. Then this is giving 122. This pi over 4, 120 minus 90. I don't have a calculator here to double check as well. 120 minus 90 square times 340. That one is giving. It's giving 1. Are you sure?
Yes. I'm even calculating again.
No. Something is off. Something is definitely very off.
Yeah, it's 1,682 times 10 to the power 6.
You know what? If it's not working like this, maybe we should go the hard way. But it has to give the answer. Okay, it is 540. I see that one. Can we try the calculator separately, ne? I want you to type. I want you to do it for me. I want you to do pi over 4, right? Times 80 squared times 40 on its own. What do we get as answer?
You said what?
Pi over 4.
Yeah.
Times 80 squared times 40. I'm just separating them like I was explaining.
Or times 40. Okay.
It has to give that answer.
It's 201.
Can you keep can you keep it with pi? What do we get with pi?
Yeah, 2,01.
Now your calculator has a problem.
Ah man, 201. 201.
No, still, if you take, what I want you to calculate is pi. Do you see pi over 4?
Yeah.
Multiply by 80 square multiply by 40. It's just the same. Yeah. What do you get?
Yeah, 201.
No, your calculator has a problem. You need to get 64,000 pi. Can you check your calculator, please?
Oh.
What do you get?
Yeah, 6400 pi.
Then it means there's something wrong with your calculator. What were you doing before when you were getting that other answer? I just want to know.
So that we before
when you were not getting it, you were typing something else. What were you typing so that I know what might be the mistake that you're making?
The time we were calculating y bar or
no, this one, just this one. Before you get 6,4, you were getting something else.
Oh, I said 2 pi. 2 over pi. I mean, pi over 4.
Pi over 4. Okay. Can you now do pi over 4? I just want to see something. Multiply by 50 square, right? Multiply by 40. What is the answer?
It's 2500 pi.
Okay, now I want you to do that 64 that you got there minus 2500. It has to give us this answer. Can you do it? 6,000 for minus 25.
Okay. It's 3900 pi.
It is 3900 pi. Okay, if you click the answer without the pi, what do you get?
122.
12252.
Yeah.
Then what is wrong here? Oh my goodness. What is wrong here? No, we have to solve this. We don't have time. Okay, can we do this one? Is fine. It's 540 times 10 to 3. Okay, right? I want you to do the same here. Can you do the same here? Can you do with your calculator? Pi over 4, right? Times 120 square times 340. What answer do you get?
Multiplied by 340. Should I put it in scientific?
What are you getting? Are you getting 3845,319 something?
Yeah.
Okay. Just keep it as answer.
Okay.
Now, can you do now pi over 4 times 90 square times 340?
Okay. It's 2,16.
Okay, this 216 whatever. Can you do now the subtraction of the first one that you did and that one?
Okay.
So what is wrong here then, God?
Yeah, it's 1,682.
It is 1,682.
10 to the power 6.
Which is basically what you were getting, 1, something.
Yeah.
Then something is off. Okay, first area, pi over 4, 80 square minus this, plus. Okay, I think we should check. What do we have as total area here? If everything is on top is fine. You said you were getting 1 here, ne?
Yeah.
1,
1,682 times 10 to the power 6.
62 times 10 to the power 6. Okay. Now, can you please take what's total area, please?
Okay. I'm calculating the centroid.
No. Total area. I just want to double check. What's the total area that we get?
Oh, okay.
We need to get it right. We need to. It's a must. Oh, my brain. Let's go. Wait, let me borrow this guy calculator. Yes, what do you get?
That's 11011.
You know what? Let's do this. Pi over 4 times 80 square minus 50 square times 40 plus 15 times 200 times 180 plus pi over 4 times 120 square minus 90 square. We close times 340. Everything pi over 4 times 80 square. The calculator doesn't want to take it. Anyway, let me start again. No, we need to get this answer, Angelia, otherwise we won't be able to move.
What is the answer?
The answer from the textbook is 212.
Yeah, I got it. 212,
comma 95.
Mine is 924.
Nah, it's fine. Even if it's 924, it's fine.
Okay.
You got 212,9, right?
Yeah.
So what was the mistake here? I just want to know what was the mistake while we were doing the calculation.
I think the total area.
It was wrong. So please, I've noticed that you are making some mistake with the calculation. Be careful, né? Please.
Okay.
You get 212,92, right?
Yeah, 924.
Okay, no problem. Millimeter. So remember, we are reading from top, so we can come and represent that 212. Do you agree that if from here to the center here is 180, right? So 212 is somewhere here. I can come and represent 212 somewhere here. Do you see? Just after 100 from this.
Okay.
Because 180 plus 100 is 180, so 212 must just be below there. So we can try to move it a bit there. Do you see it now? Now the distance from here to here is what we call our y bar. And always come and mention that your thing is from what? Is from top. You see, during the test, when you'll be doing this, you don't have an answer to refer to. So what does it mean? The mistake that we made earlier, if we consider that answer, it means it is wrong. And if your y bar is wrong, everything is wrong.
Okay.
So please be careful with the calculator. Now what do we do from here? Can I move a bit faster, ne?
Yeah.
We start by ix. By ix, remember I've given you. Let's start by ix1. ix1 is the first alu. Do you see it?
Yeah.
Now where is the center? Where is the centroid find? Where is the center of gravity? Is this one? Do you see it? So basically what is happening, if I can show my ruler here, we have this axis here. Do you see it now? Now what do we need? We want to solve for moment of inertia, because you can see these two axes here, this one and this one is parallel, therefore we'll have what? Parallel theorem, right? Now first we start by writing the one for the alu, which is pi over 64, right? What is the big diameter? 84 minus 54, right? Now what is happening? Plus what? Area. It is parallel theorem. The parallel theorem says that I is equal, let's say it is ix is equal I of that thing plus the area times h square. Do you see it? This is the I. Next is the area. What is the area? The area is pi over 4 h square minus 50 square. Now multiply by, this is what is important. What is our h? In this case our h is the distance from this guy to y bar, from here to here. How do we get this h? Now we have to use our math. We have y bar given. Do you agree that if we have y bar minus this distance on top here, it gives us the h?
Yes.
So it is 21294 minus what? The radius. Do you see it?
Yeah. Minus
40. 212,924 minus 40 square. This give ix1. What is the answer?
Okay, the answer is 93.
93, comma
297.
10 to 6,
Yeah.
which is a millimeter 4. Can we do ix2? What is ix2? It's the rectangular, right? For the rectangular, you know I is what? It is b h cube over 12, right?
Yeah.
So first of all, we know that the rectangular center is here. So what we need is this distance h, right? So these axes are already parallel. So what we're gonna have is 1 over 12. What is the base?
It's 15.
And what is the height?
200.
So 15, this is 15, sorry. To the 3. To be equal to
12 over 12.
Plus
Yes.
area, right?
Yeah.
15 times 200. Multiply now by the distance from the center of gravity. No, the distance from this center of gravity to y bar. So if we have to do the math, it's going to be what? It's going to be y bar minus 180. Do you see it right?
Yeah.
Thank you. So it's going to be 212,924 minus what?
180.
Minus 180. Yeah, square. What is ix2?
It's 13.
Is 13?
0.252
0.252
times 10 to the power 6.
times 10 to the power 6. Millimeter 4. Then we go to the next one. The next one is also an alloy, right? This is the alloy. But now what's gonna happen is simply the axis here that we'll be studying here. Remember, the axis of this guy here is do you see it?
Yeah.
So the distance h now would be from that y bar to here. So can we do the math first? First we have pi over 64 multiply by what? What is the bigger diameter? 124 minus 94 plus what is the area? Pi over 4. 120. Is it 120? Sorry, my brain is freezing. Please follow with me. I don't want to make a mistake here. I feel like my brain is freezing. So what is the distance now? What is the distance h here? We have to do the math together.
Okay. The distance is y bar.
It is y bar. What am I saying? No, for me the distance, I think, not I think. Do you see y total? The total length of this thing, it is 80. Are you with me, Angela? Hello? Hello? Please talk to me, talk to me.
Hello?
Yes, can you hear me now? I think you got a network problem. Can you hear me now?
Hello?
Hello, can you hear me now?
Yeah, I can hear you.
Yes, I was saying, if you take the total distance of this shape, what do you think it is? 80, right? Plus 200 plus 120. Do you see it?
Can you explain again?
If you want to get the total length of this wall shape, do you agree we have 80 diameter, right?
Yeah.
Plus this 200 plus
Yeah.
this 120. Are you with me on that one?
Yeah.
So do you agree that if I take, right, total length, let me show it with the ruler so that that we are on the same page. Let me use the technology. This is total length. Do you see it? Do you agree that if I take total length minus y bar, what I'm left with is this one?
Yeah. Yeah.
And
Okay.
if I take this one minus 60, I have this distance.
This one minus 60. Okay. Okay.
You have the remaining length that we are looking for.
Okay.
So can we do that? Can you give me the total length? I'm gonna write it like that. What is the total length?
So it's 180 plus 200 plus 120. Total length, it's 400.
Okay, we have 400. Can I say 400 minus 60? Do you agree with me? Minus y
Yeah.
bar, minus y bar as well.
Okay, minus. Okay, now calculate.
What is the answer?
The answer is 86.
The answer is 86, comma.
860 times 10 to the power 6.
Okay, let me write 86 times 10 to the 6. Can you please add this one, this one? You can forget about the 10.6, just add this number. Let's see if we're gonna get the ix. The ix that they got here is 193. Can you please add 90 comma this plus 13 comma this plus 86 comma 86? What do we get?
193.
Yeah, 193 comma, this is the I that you're looking for. 193 comma
409.
409. Then yeah, it's 409. Millimeter 4. Now what is next? Yeah, that's what they got. For IY, we're gonna do the calculation of this one without the parallel axis.
Okay.
Yeah. Now there's something that I want you to do before we meet. I want you to try this one on your own. Please.
Yeah.
And I want to try it tonight because you are writing tomorrow.
Yeah.
What are you
I'll
doing
try
after
tonight.
here? Yeah, you send it to me tonight. I'll look at it, and yeah, I don't want to come back to this tomorrow. Tomorrow we have a long night.
Okay.
Hmm.
But I did try it yesterday.
What did you do?
I did try to do it yesterday. Just that I didn't get the correct answer.